So I'm picking right up where we left off with example 2 continued. We've got a little bit more information now. And we know that the profit per acre is $60 for corn and $40 for soybeans. So how many acres of each crop should the co-op plant in order to maximize their profit? Well, it would be obvious. We would want to plant everything with corn if we could. We would plant all 6,000 acres. But if you recall, corn was our X value. And if we planted as much corn as possible, we can only plant 4,500 acres because we are lacking in fertilizer and hours to do all 6,000 acres. So we are limited and can't do all 6,000 acres in corn, even though it's the more profitable crop. So what we need to do, everyone, is construct a profit function and then test each of these values to see which one is going to be the most profitable for this farmer. So as we have done in example 1, very similar, corn, revenue for corn is $60 per acre. And so for a profit function, corn would be 60x, or $60 per acre. Soybeans would be 40y, or $40 per acre. And again, you see I've matched my X with my corn and my Y with my soybean. So a total profit function would be equal to 60 times the number of acres of corn plus 40 times the number of acres of soybeans. And so as I mentioned, everyone, very simply, what we are going to be doing now is taking each one of these values, putting it into that profit function, and testing it. So I'll write these down on my iPad here, and then we'll put them into Wolfram. So for point A, we would have 60 times 0, because there would be no corn planted, plus 40 times 5250. Option B would be 60 times 3,000 plus 40 times 3,000. And a lot of people, it seems like, defer to, hey, let's just do half and half. And that might be the best option, but we might get a surprise, and that might not be the best option. In fact, there might be a huge difference. We will find out. So 60 times 3750 for corn, plus 40 times 2250 for soybeans. And option D is 60 times 4,500 acres of corn, plus 40 times 0 acres of soybeans. And so again, everyone, given our constraints of acres, fertilizer, and hours, these are the options that this farmer has to distribute the planting of the fields. So coming to Wolfram, we are going to have each one of these, and we're going to test it. So we've got 60 times 0 plus 40 times 5250. And that's going to come out to be $210,000. That sounds pretty good. Let's check some others. Well, I think I made a typo. Let me make sure that that's actually, yep, $210,000. Okay. So next we have the option to plant half and half, 3,000 acres of each. If we were to split it, we do make more money. We make $90,000 more with this option. And that's 300,000 bucks. So if I'm a farmer, I'm definitely paying attention to someone who knows how to do this kind of math, because I just made this farmer $90,000 by telling them to plant half corn and half soybeans. Let's see if there's a better option for this farmer. So 3,700 acres of corn and 2,250 acres of soybeans gets this farmer another $15,000. So I just made the farmer $15,000 for doing nothing, but except for increasing the number of acres with corn and decreasing the number of acres with soybeans. Lastly, everyone, we're testing pure corn, which we know the price of corn is way better than the price of soybeans in this problem. Let's see what going full corn does. Full corn goes 270,000. So in rank order of our options, this is option number 1 that we want, number 2, number 3, and number 4. So the best option by far, by a margin of $15,000, is to plant 3,750 acres with corn and 2,250 acres with soybeans. And so again, as we mentioned, everyone, if we go from our lowest to our highest, there's a $105,000 difference between this choice and this choice. So again, if I was a farmer working in the Yakima Valley and someone came with the knowledge of math of how to do this for me, I would be paying them a lot of money. Maybe someday you will be that person. Wouldn't that be cool?